Okay, so I'm not sure what the issue is. I have started the live streaming again. It seems there's some problem with the live streaming. So I have done it again. So yes, in case of ternary operator, so here is an example which is used to find the largest of two numbers, and whichever is the largest number, I'm going to assign it into a variable called num3. So first I'm checking a condition if num1 is greater than num2. If the condition is true, num3 is assigned with the value of num1, which is 10. Else, num3 is assigned with the value of num2, which is 20. So after that, we are trying to print the value of num3. So value of num3 here is whichever is the largest gets assigned. So 20 is assigned to num3. So 20 will be printed as an output. Now how to substitute this with a ternary operator is any condition you have written here, I'm going to have it as a condition written in the ternary also. So num1 greater than num2. And after that, there is a question mark to indicate that it is a condition. And if the condition is true, num1 will be evaluated and it will be returned. So if you remember, the operator of C programming language does two things. It performs the operation as well as returns the output also. So here also, after num1 is greater than num2 is checked, you are going to return the value of num1 to the variable num3 if the condition is true. And if the condition is false, the value of num2 is returned to the variable num3. So that is how we are going to replace if else block with a simple ternary operator. So it is optimized if you have a ternary operator and return in place of an if else block. So it is always said as an optimized code because it reduces the number of lines while a program is being returned. So if you have very simple set of statements to be solved, if a condition is true or if a condition is false, then you can substitute the if else block with a normal ternary operator. In the previous, you said about installing the software. Please say how to use them. So softwares, you just please keep it ready. That is for the sake of the project we are going to do ahead. Okay, so that is for the sake of project, how to make use of the software, how to use the tools and all, you will know when the time comes. Okay. So yes, let us continue. So that was a ternary operator. Let me execute this and show you the output. So I'm using this files. Does ternary operator reduce the time complexity? So no, actually it will not reduce the time complexity. So what it takes for a if else block to get executed, it takes the same amount of time. So it is not going to reduce the time complexity as such, but it is going to reduce the space complexity. So it reduces the number of lines in the code. So accordingly, you can see that the executable file size is going to get reduced. So I'm taking an online compiler and let me have the program executed. So this is to find the largest of two numbers with the help of if else block. You can see the value of num3 being displayed is 20. So now the same we can get it with the help of a ternary operator also. So in case of ternary operator, so a normal if else block is being replaced with simple line here. So num1 greater than num2, the value of num1 will be assigned to num3. And if num1 greater than num2 is false, the value of num2 will be assigned to the variable num3. So if you print the value of num3, you are still getting 20 printed as an output. But remember, you cannot do something like this. If the condition is true, you might say num3 is assigned with num1, and if the condition is false, you might say num3 is assigned with num2. But this is in fact not the right way of writing a ternary operator. This will end up giving me a error. Now if you observe here, the function main, okay, so there is an error, L value required as the left operand. Now the biggest reason behind that is, if you look at the man page of the operator, I mean if you look at the precedence and the associativity table, so ternary operator will have the highest precedence compared to that of an assignment operator. Okay, so ternary has to have a highest precedence compared to assignment operator. Now what happens is, in the expression you are taking, so before solving the ternary operator here, you cannot have an assignment operator considered. Okay, so please understand, assignment has lowest priority, ternary has the highest priority. Now to have the ternary operator solved, there is an assignment operator involved which is having lowest priority than that of the ternary operator. So this is leading me an error. So how to solve this is, you may have to create a parenthesis like this. So now what's happening? Because the grouping is already done and parenthesis has the highest priority, this whole thing will be seen as expression 1, this whole thing will be seen as expression 2. So now this has to work fine. Num1 greater than num2 condition true. Num3 is assigned with num1 and num3 is assigned with num2. So we have to print the value of num3. We are going to get 20 printed as an output. So that is one thing you have to remember in a ternary operator. A ternary operator is a substitute to the normal if-else block. Is this clear? Okay. Now there is something called as overflow and underflow. So another topic which happens in signed variables. What do you mean by signed variables? So what do you mean by signed variables? What type of values can be held inside a signed variable? Yes, so I can either store a positive number or it is a negative number, positive or negative number. Okay, now in case of a signed character, so assume I have taken a signed character, so something like this, signed character CH. Okay, can you tell me what is the range of values I can store inside the signed character? What is the range of values? I can store both positive and negative number. So from what value to what value I can have a data stored inside a signed character CH. Yes. So we can have the value stored from minus 128 to plus 127 because it is a signed character. So character is going to get 1 byte of memory allocated. In that 1 byte, I can store any value ranging from minus 128 to plus 127. Now assume there is a situation where inside CH, I'm trying to store 129. Okay, I'm trying to store 129 inside a variable CH. Now the range of signed characters says I can store any value between minus 128 to plus 127. But I am trying to store 129. Do you think this is allowed? Do you think storing 129 inside CH is allowed? Okay. Now please remember, this is fine. Okay. So this is not giving you any error. I would say it is fine and no error. But the problem is, because I'm trying to store a value which is not in this range. Okay. Because I'm trying to store a value which is not in the specified range. This situation, Where I try storing a value beyond 127 is called as overflow. Okay, so trying to store a value beyond 127 is something called as overflow. Okay, you're trying to store value beyond 127, you call it as an overflow. So you are trying to store 129 here because it is beyond 127, we call it as overflow. Then what exactly is stored inside CH when you are trying to store 129? So what is stored in CH, okay, when 129 is stored? So remember, to know what value is stored inside CH, we are going to do 129 minus 256. Okay, so 129 minus 256. Can you tell me how much is this? So how much is 129 minus 256? So it has to be minus 127. Okay, so when you tried storing CH with 129, there is minus 127 being stored. Remember, CH is character, so shouldn't that be written inside a single quotes? Okay. So CH is a character which is also referred as 1 byte integer. So even if you try storing a character inside CH, there is an ASCII equivalent being stored which is an integer. So character is always referred as 1 byte integer also. You call character as 1 byte integer as well. So inside character, you can store any value ranging from minus 128 to plus 127. So if I try storing a value beyond 127, we call it as overflow. Now to know what value is stored inside CH when you tried storing 129, so it is 129 minus 256. Now we must be wondering how to get 256. It is 2 power n, where n is nothing but 8 for a character. Okay, so n is equal to 8 in character. Okay, so that is CH. So what is stored inside CH? 129 is stored. It is 129 minus 256. So minus 127 is stored. So let me show you that here. So I'm going to take a character variable called CH. Okay. So by default, CH is of type sign. I try storing 129. So let me print percentage D equivalent of CH. So I will get minus 127 printed. So you can see minus 129. Similarly, I try storing minus 129 into CH. So I will try storing minus 129 to CH. What do you think gets stored? When I try storing minus 129 in CH. So I'm doing CH is equal to minus 129. Okay. So to know what value is being stored inside CH, so you have to know CH plus 256. So CH is minus 129 plus 256, okay, which is nothing but 120. Is that 127? Okay. So 127. So there is plus 127 being stored when you have tried storing minus 129. You can see it is 127. So what you are supposed to do is plus. Okay. So if you try storing a value beyond 127, you call it as overflow. And if you try storing a value below minus 128, you call it as underflow. So here you are trying to store plus 127 plus 1. That means you are trying to store plus 128. So It will not give you any error. It might store some other value inside it. So, and that is the case which happens only in signed variables. So trying to store the value beyond 127 is overflow. And let me also see. This is again fine. Okay. So trying to store a value below minus 128. Below minus 128. We call the situation as underflow. Why there is no error when we are storing integer using character data type? So I'm repeating this again. So character is nothing but 1 byte integer. Even though you try storing a character internally, there is an integer being stored. So internally integer being stored, that means you literally can store an integer also when you require. So if you have only 1 byte of integer to be stored in the computer's memory, you don't have to take for an integer because integer gets 4 bytes of memory block. You can just deal with the character which gets 1 byte of memory block. So integer is also referred as, character is also referred as 1 byte integer. Is that clear? What about the special character? Any special character you want to store inside the character, it has to be available in the ASCII table. Okay. So any character you want to store inside a character variable, it has to be available in the ASCII table. So that character will be stored inside a character variable according to the ASCII equivalent. Does overflow underflow affects the program's execution? Yes. So let's say you are trying to store minus 129. Keeping minus 129 in mind, you might do some operations. But actually, there is just 127 being stored in the computer's memory. So it may affect the calculations, which depends on the value you have stored. So which is why you have to be aware of overflow and underflow. Is that clear? Okay. So that was the concept of overflow and underflow, which is seen on character variables. Now let us move to one important concept, which is nothing but array. When do we use overflow and underflow? So it is not something you personally use. Both overflow and underflow happens when you try storing a value out of the range. So as you see here, if you try storing some value beyond 127, it leads to overflow. If you try storing value lesser than minus 128, it leads to underflow. So it is not something you will use. It is something which basically happens by itself if you overrule the rule of a character. So that is not something intentionally made, but you have to be aware of what happens in such situations. Okay. So now let us proceed with the next topic. What happens with unsigned variables? Okay. So in case of unsigned variables, you always store a positive value. So you're not going to store any negative value. It is always a positive value. Now, because it is always positive, we don't have a scenario called overflow or underflow. Okay, so it is always a positive value. There is nothing called overflow and underflow which happens in unsigned variables. So you store only a positive value there. Okay. What do you think is an array? How could we know where CH is 127 or greater than that? It depends on the value you're trying to store inside CH. Overflow, I made it wrong. Let me check. Trying to store a value beyond 127. That is right. This over. Oh, this is underflow. Sorry, underflow. Okay. Yes. Okay. So I was asking what is an array? Sequence of characters. Okay. Array set of elements. Okay. Group of similar elements is called as an array. Fine. Data structure consisting of collection of elements of same memory size, each identified by at least one array index of, I don't know what is that. Okay, collection of similar elements. That is right. So when you are asked to say what is an array, so array is nothing but the collection of similar kind of elements. Okay, so collection of similar kind of elements is nothing but array. And when it comes to the array, please remember that the array is having similar kind of elements and the memory for elements are allocated on a continuous manner. So collection of similar kinds of elements and memory for the elements, okay, is allocated on a continuous manner. So elements, memory for the elements is allocated on a continuous manner. Okay. Now the very first question comes is, why do you actually need an array? So is it necessary for you to go for an array is the question. Now please understand, yes, it is necessary because assume I want to deal with 5 integers. So I declare 5 integers like this. Int num1, then I go with int num2, then I go with int num3. So let's say int num4 and int num5. How many bytes of memory is allocated for each integer here? How many bytes of memory is allocated for each integer? Okay, so you are still confused with 2 and 4. So it has to be 4 bytes in the GCC compiler. So for integers, it is generally 4 bytes depending on the bitness of the system. So each integer is going to get 4 bytes of memory allocated. Now to store these 5 integers, totally how many bytes of memory will be occupied? Yes. So because I'm trying to store 5 integers, each of 4 bytes, there will be 20 bytes of memory being used. Now the problem is, this 20 bytes will not be allocated on a continuous manner. Okay. So the 20 bytes will not be continuously allocated. Instead, somewhere in the memory block, 4 bytes will be allocated for num1. Somewhere in the memory block, 4 bytes will be allocated for num2. So somewhere in the memory block, 4 bytes will be allocated for num3. So randomly, the variables are going to get the memory allocated. All the 5 integer variables are going to get the memory allocated on a random manner. Now what happens with this is the memory is allocated on a random manner. So once the memory is allocated, okay, so what exactly happens is after the memory is allocated, whenever you are using it, you may have to go to the random memory and you may have to use it. Okay, so you may have to go to the random memory and you may have to use it. So now what happens with this is whenever you are trying to allocate the memory, because let's say you want 5 integers and memory is allocated on a random manner, accessing them is quite challenging. Now assume these 5 integers, you want the memory to be allocated on a continuous manner. Okay. For these 5 integers, I want the memory to be allocated on a continuous manner. I want them to be placed one after the other continuously. So that is when we need a concept of arrays. When you want the memory to be allocated on a continuous manner, and all of the 5 values should be referred with the same name. So that is when arrays plays a very important role. So instead of me taking 5 integers like this, because I want 5 integers to be stored, I take an array called array and I write 5 here. Okay. So now this is an array which is used to store 5 integers. Array used to store 5 integers. Okay. So like this you are going to get 5 integers stored. Now after the 5 integers, this is an array I have declared. So if you want to know how much is the total memory allocated for this particular array, okay, if you want to know the total memory allocated, so you are going to make use of the size of the array, okay, multiplied by size of the data type of the array. Okay. So size of the array multiplied by size of the data type. In this scenario, how much is the size of the array? In this scenario, how much is the size of the array? Yes, the size of the array is 5 multiplied by size of the data type is size of integer, which is nothing but 4 bytes. So 5 multiplied by 4, there will be 20 bytes of memory allocated for this array. Similarly, assume I have a character array called ch of size 10. Okay. How much is the total memory allocated? How much is the total memory allocated for this? So size of the array is 10 multiplied by size of character is 1. There will be 10 bytes of memory allocated on a continuous manner. Then I take a double array called age, okay, of size 4. Can you tell me how much is the total memory for this? Yes. So it is 4 multiplied by size of data type is double, which is 8. So 4 multiplied by 8 is 32. So there will be 32 bytes of memory allocated. So like this, the memory will be allocated on a continuous manner. So this is how you declare the array. First you specify the data type, the name of the array and the size. To know the total memory allocated, it is size multiplied by size of the data type. Now if you declare just an array like this, okay, so assume I take an integer array called arr of size 5. What will be stored inside this array? What will be stored inside this array of size 5? Okay, so there will be 5 garbage integers being stored in the memory. So there will be 5 garbage integers stored inside the array of size 5. Now if you want to store any specific value while the memory is being allocated, you can do int arr of size 5, and also because it is multiple values, you have to create a block like this, and you can represent 5 values 10, 20, 30, 40, 50. Okay. So now ARR gets 20 bytes of memory allocated. First 4 bytes will be used to store 10, then 20, then 30, then 40 and 50. So you are going to have 10, 20, 30, 40, 50 stored like this. Okay. So that is an integer array of size 5. So if I say 10, 20, 30, 40, 50, it is being stored in the computer's memory. Now please remember the points to be noted. An array is a collection of data of same data type. Okay, so an array is the collection of data of same data type. Addresses are sequential. So for example, if the array is starting from the address 1000, okay, first element is address 1000, second element is at the address 1004, third element is at the address 1008, then 1012, then 1016. So memory will be allocated on a continuous manner. First element will be in the lowest address and last element will be in the highest address. You can see the first element is in the lowest address 1000, last element is in the highest address which is 1016. Then indexing starts from 0 and should end at size minus 1. Okay. Now what is this indexing is? That is the way of accessing the elements of the array one after the other. So if you want a particular element of the array, you're going to access it with the help of indexing. So 10 will be present in the index 0, 20 will be present in the index 1, 30 will be present in the index 2, 40 will be present in the index 3, and 50 will be present in the index 4. Okay, so you can access the elements of the array with the help of indexing, which varies from 0 to size minus 1. If the size of the array is 5, the indexing of the elements varies from 0 to 4. If the size of the array is 7, the indexing is going to vary from 0 to 6. If the size of the array is 10, okay, then the indexing is going to vary from 0 to 9. So indexing always varies from 0 to 9 or 0 to size minus 1. Now if you try accessing the elements of the array beyond the index, okay, so you can access to get the value 10. How will you get? How to get the value 10 inside an array of size 5? To get the value 10, what you can do is, it is array of 0. When you say it is array of 0, you get the value 10. Similarly, how to get the value 40? How to get the value 40? So it is again the indexing. So 40 is present in the index 3. So to get it, you have to do, sorry, it is not here. So 40. So array of 0 is going to give me the value 10. To get the value 40, you have to do something called array of 3 like this. Okay. So if the size of the array is 5, indexing varies only from 0 to 4. So you can only access array of 0 to array of 4. In this case, do you think I will get an output if I try accessing array of minus 1? Do you get an output if I try accessing array of minus 1? Yes. What do you think array of minus 1 is representing? What is array of minus 1 representing? Is it representing 50? How? No, it is not representing anything. Please understand, array of 0 is 10, array of 1 is 20, array of 4 is 50. Okay, array of minus 1, there is no index called minus 1. So array of minus 1 is not there. So when you try accessing array of minus 1, it might end up giving you some undefined behavior. It might give you some garbage value. Sometimes it might give you a runtime error called segmentation fault also. Okay, so remember that this is name of the array. Okay, so yes, I have taken the array as ARRAY. Okay, so I have taken the name of the array here. So when I say array of minus 1, So this is going to lead to an undefined behavior. Okay. So that is array of -1. Similarly, if you try doing array of let's say 5, do I have an element in the index 5? If I have taken an array of size 5, do I have an element at the index 5? No. Again, array of 5 might also end up giving me an undefined behavior. In fact, it is not legal for you to access the array's index which is beyond the range. So here the array's index varies from 0 to size -1 only. If you try accessing an array element out of the boundary, it is going to lead to an undefined behavior. Any accessing of beyond the boundary would lead to illegal accessing. For example, array of -1 or array of size, which leads to an undefined behavior. Okay, so that is nothing but an array. Okay, now I will go with a simple example. I have, let's say, a array. I will go with a simple example. Negative indexing is supported in Python, why not in C? So that is how it has been designed. So indexing for arrays varies only from 0 to size -1. Okay. So I take an integer array called ARR of size 5. But remember, when you're doing the initialization, you don't have to specify the size. If you are doing the initialization, size is not specified. So I'm initializing it with 10, 20, 30, 40, 50. Okay. So I'm initializing it with 10, 20, 30, 40, 50. Can you tell me how many bytes of memory is allocated for ARR? How many bytes of memory will be allocated for ARR? Yes. So there will be 20 bytes of memory allocated for ARR. Now how is the 20 bytes? I have got ARR which has been initialized with 5 integers. I have taken an array of type integer. It is initialized with 5 integers. So 20 bytes of memory is allocated for ARR. What do you think the indexing varies from? What will be the index? Index of these elements? Yes. The indexing of these elements will be 0 to 4. Okay. Now I want to print the elements of this array. I want to print the elements of this array. Which function should I use? To have the elements of the array printed, which function should I use? I have to use the printf function. Can you tell me to the printf function what should be passed so that I get 20 as an output? What should be passed so that I get 20 as an output? So to the printf, what should be passed? Yes, the indexing 1. So %d \n, comma, name of the array is ARR. Its index should be specified in square braces, which is nothing but 1. Now I want all the elements of the array to be printed one after the other, starting the index from 0 to 4. So I want this statement to be repeated from index 0 to index 4. So what do you think I should be using here if I want the statements to be repeated again and again? I need a loop. So I will make use of a for loop. So for the loop to run, I need an integer variable called I. So I will say for I is equal to 0, I lesser than 5 and I plus plus. Okay. So inside this, I'm going to print the value of what? So array of, what should we be writing here? Yes, so I should be using I here. So what is happening? I is initially 0. Array of 0 will be printed, which is nothing but 10. Then I plus plus will take the value 1. 1 lesser than 5 is true again. So array of 1 will be printed, which is having the value 20. So then array of 2 will be printed, which is having 30, 40 and 50 will be printed. Okay. So after this is printed, when I takes the value 5, 5 lesser than 5 is condition false. You come out of the for loop. So I'm running here. You can see the output. So it is printing 10, 20, 30, 40, 50. A small warning because I have not returned the headers inclusion. So let me include the header as include stdio.h. So you can see this is going to print the elements of the array one after the other. Okay. Now I want to read into the array and then print its elements. I want to read into the array's elements and then print its value. So how do you think I can read into the array? How can I be reading into the array? Yes, I need a scanf function. So I'll copy paste this. Okay. And instead of printf, because I want to read, I have to make use of a scanf function. So first I will give a printf saying enter the array's elements. Enter the array's elements. Okay. Then I'm running a loop. So percentage d equivalent of, there is no backslash n and this has to be scanf. Okay. And percentage d equivalent, now I have to give address of ARR of I, because the scanf always takes the address of the variable to be read. So address of ARR of I. Then I enter the elements. I will have one more statement added. Printf the array's elements are. Okay. So with the backslash n, so I'm going to get the elements of the array. You see here. In fact, I have initialized. If you want, I will not keep it initialized. But when I'm not initializing the array, it is necessary for me to specify the size. I will take the size as 5. So I'm running now. Now enter the array's elements. Let me enter 5 elements because I'm running the loop for 5 times. I'm entering 10, then 20, then 30, a 40 and a 50. Okay. So after that, if you see, it prints array's elements are 10, 20, 30, 40 and 50. So that is how you are going to read the elements. So here we have a do by loop return instead of a for loop. So whichever loop you are comfortable with, you can use. So whether a for loop, while loop or a do while loop. So this is elements, printing the elements of the array with the help of for loop. This is reading the elements of the array with the help of, sorry, this is again not reading, it is still printing the elements of the array itself. So for reading, you have to go with scanf function. Okay. Now look at this. How many bytes of memory is allocated for ARR1 here? How many bytes of memory is allocated for array 1 here? Yes. So because you have specified the size as 5, always size is given the highest prominence. I have specified the size as 5 and I'm trying to store 5 integers. So there will be 20 bytes of memory allocated. Okay. So array 1 will get 20 bytes of memory allocated. What about array 2? What about array 2? So here I am trying to specify the size as 5. Always when size is specified, it is given the highest priority. So because the size specified is 5, I will get 20 bytes of memory allocated. But what about the index 2, 3, 4? Index 0 has 1, index 1 has 2. What about index 2, index 3 and index 4? What will it have? Okay. So please remember, this is a partially initialized array. Okay. So this array is partially initialized. So this is a partially initialized array. Now, in case of a partially initialized array, you will have the rest of the elements initialized with 0. Okay. So rest of the elements will be initialized with 0. So the elements of this array are 1, 2, 0, 0, 0. Partially initialized array will have 0 return in the non-initialized part. Now, how much is the size of the third array? Array 3. How much is the size of the third array? So it is 8. Because I'm trying to initialize, will you please answer me? Aishwarya, what is your doubt? I missed your doubt. Can you please repeat? Hmm. For I is equal to 1, I less than or equal to 5, I plus equal to 1 can be used. Prakul, okay. So Prakul, what you are saying is, if you start with indexing 1, you might end up skipping the first element. Indexing always starts from 0. So you will skip the first thing. So you will not be able to get the first element. Login issues with the LMS, you just have to check with the support team. Okay. And what about where I have to watch those videos? So we have the recorded sessions which are uploaded in LMS. So which to the portal we are logged in. So you can access the recordings in the LMS by yourself. Okay, I was asking about how much is the size of array 3. How many bytes of memory will be allocated for array 3? So because I am trying to initialize array 3, I have not specified the size. So I have just initialized array 3. Now because only array 3 is been initialized with only 2 integers, okay. So it will be the total memory allocated will be 4 plus 4, 8 bytes only. Okay, the total memory allocated will be 4 plus 4, 8 bytes only. So that is about the total memory allocated. Okay. Yes, so when it comes to array 3, so array 3 has been returned with only 8 bytes. So first you will have indexing 0 with the value 1, indexing 1 will have the value 2. About array 4, so please understand, when you take an array, you have to either initialize the array or you have to specify the size. Whenever you declare an array, You either have to initialize the array or you have to specify the size. So here you neither have initialized the array nor you have specified the size. So this is going to be an invalid statement. Okay. So this one will be an invalid statement as you have not got any of the initialization or the size specification done. Percentage D is for integers and numbers. What is percentage U? So percentage U we have discussed, it is to print an unsigned integer value. Okay, it is to print an unsigned integer value. Yes, we will take a break. Before that, can you please answer the printf's value? How much is size of array 1? So array 1 is getting 20 bytes of memory allocated. So size of array 1 will be 20. Size of array 2 will be, array 2 also gets 20 bytes of memory allocated as you have got uh, the size specified as 5. So that also gives 20. Size of array 3 will be 8 because it has got only 8 bytes of memory allocated. So size of is an operator which tells the total memory allocated for that particular array. Okay. So yes, let's take a break of 2 minutes and then we will continue. If we take user input is not size specified array, will it give error? So size also you can read it from the user itself, and after you read the size, you can allocate the memory. You can declare. So in that case, it will not give you any error. After you read the size, you have to allocate the memory for the array. That is important. Okay, please take a break of 2 minutes. We will continue. Okay, let us continue. Ma'am, please tell about the quiz. When are you going to post it? Okay, so quiz is something which happens after the module gets completed, after this particular topic gets completed. So it should be scheduled anytime in this week. Okay, you please be prepared. Once the C module gets over, you will have a quiz associated to it. Okay, so that was about the initialization of the array and printing the array's element. Now you have a simple question here. Can you copy two arrays like this? Sarfaraz is asking in TRR. Okay, let me just copy that question. Okay, there is in TRR. You have taken int I for, okay, there's a for loop, then there is a printf. What happens? We loop out of the index value. So as I said, this has to lead to an undefined behavior at some point of time. And it might also end up giving you an error called as segmentation fault. Okay, so it can be any of this. Okay, so it can be an undefined behavior. Okay, so I was asking, will you be able to copy two elements like two arrays like this? So the answer to this question is no. You cannot copy two arrays like this. Copying two arrays is not this simple. Now the reason why this is not simple is, when you are going to copy two arrays, let me represent you one thing. So first array underscore org of size 5. What do you think? How many bytes of memory is allocated for the first array? How many bytes of memory is allocated? So we are going to have, there is 20 bytes of memory allocated for the first array. And in this 20 bytes, let's say the starting address is 1000. Okay, so first element is present in the address 1000, which is having 1 stored inside it. Next element is at the address 1004, having 2 stored inside it. The other next element is in the address 1008, having 3 stored inside it. Then 1012 has 4 stored inside it. 1016 has 5 stored inside it. Similarly, array underscore BAK also has got 20 bytes of memory allocated, but all the 5 elements are initialized with some garbage value. And let's say array underscore BAK is getting the memory allocated from the address 2000. So now what happens is, when you say array underscore BAK is equal to array underscore org, they are the names of the array which represents the address where they are present. Array underscore BAK represents the address 2000, and array underscore org represents the address 1000. I'm trying to do 2000 is equal to 1000. Can you do something like this? Can you give a value 20 to the value 10? Is it possible to give a value 20 to a value 10 like this? Can I give a value 20 to a value 10? That is not allowed. So here also what I'm trying to do is, I'm trying to assign 1000 to an address 2000. So trying to write 1000 to the address 2000 is not allowed. So 2000 is being assigned with the value 1000, which is not allowed. So this is going to give you a error. When you try copying two arrays like this, it ends up giving you a error. And the error says you are trying to copy two arrays. Let me show that error directly here. Okay, so this I have executed. This executed. This is known. So I'm going to copy this program. Copying two arrays is not the simple, so it is going to give you a error. So I'm running this program. You can see the error assignment to the expression with the array type. So you cannot assign two arrays like this. It is going to give you an error. Then how to solve this? How to copy two arrays element? You have to copy it index by index. Okay. So if you want to copy the elements of the array, you have to copy it index by index. Okay. So that is nothing but the concept of the array. So is that clear with the arrays? The arrays concept clear? So you just have to know array is a collection of elements of same data type and memory will be allocated on a continuous manner. The name of the array always represents the address where the array is present. Okay. So name of the array always represents the address. So here the address of the array is one array is 1000, the address of another array is 2000. You are trying to do 1000 is equal to 2000. So that is going to give you a error. Copying two arrays is not simple. You have to copy it element by element. Okay. So if you want to know how to copy these two elements, okay, so if you want to copy the elements of the array from one array to another array, yes, I will show. So you have to do it element by element. So I'm going here. Sorry. Let me go to the online compiler. So I have two arrays here. So to copy, I need a for loop. For that, I take a integer variable called index already. So to copy the elements, first I take a for loop. Index is equal to 0. Then index is lesser than 5 and index plus plus. So whatever is inside array org, you want to get it assigned to array bak. So array bak of I is equal to array org of I. So this is how you copy. Whatever is in array of 0, sorry, array org of 0 gets returned to array bak of 0. Whatever is in array org of 1 gets returned to array bak of 1. So like this you copy. Now let me show you the contents of array bak. So I will go with the printf saying elements of okay, so elements of array bak are, okay, so I again need a for loop. So I'm going to take the for loop and this time I'm going with printf %d \n comma array bak of index. Okay, so it is not I'm sorry, I have to write index here. Okay, and these places also it is index. Okay, so this is how you are going to copy the elements of the array. You can see after copying elements of array underscore bak are 1, 2, 3, 4 and 5. So you are going to copy the arrays element one after the other like this. Understood arrays? Okay. So that was with respect to the arrays. Let us proceed ahead. So after the concept of arrays, we have one more important and a special feature of the C programming language, something called as pointers. Okay, so we have something called as the pointers, which is a very special concept associated to the C programming language. So what happens in the C programming languages? Okay, so I have a program. I mean, you have a memory to be allocated, and once the memory is being allocated, so you are supposed to access that memory. Okay, and accessing the memory is not simple when it comes to the programming language. Memory is always a topic of concern, and accessing the elements from a memory or getting the data from the memory is not easy. But when it comes to the C programming language, it is easy to play with the memory as well, because we have something called as uh, the pointers. Okay, so we have something called as pointers. What is two-dimensional array? So two-dimensional arrays is like, this is a single dimensional array what you have seen so far. So two-dimensional array is nothing but the one which represents the elements in forms of rows and columns. So that is an advanced topic, and that is not at all required for the internship right now. So we are not going to concentrate on that. I'm so nervous with the pointers concept, man. I had tried to learn and code, but I can't get a single thing. Okay. So let us see how to make use of the pointers here. Now, pointers for few people, it may feel a little difficult, but it is in fact not at all difficult if you are practicing it well. Now, let us try understanding what exactly is a pointer, and then we are going to make use of these pointers to do some operations in our programming. Okay. Could you explain about a character array? Character array is just nothing but an array of other characters. So you have an integer array, you can also go for a character array. So let's say the name of the character array, I keep it as name, and I am going to specify the size as 10. So I can store 10 characters inside this name. So the 10 characters, you can say it like this: character A, character B, character C, character D, then character E, like this. You can have 10 characters stored, or if you want, you can partially initialize where other indexes are going to get returned with 0. So that is a simple character array. How can you log into the LMS portal? You will be given with the credentials. You please check with the support team if you are not able to get it. Okay. So yes, I was talking about the pointers. First, let us know what are the important things in the pointers, like why do we literally need pointers. The very first reason to have pointers studied is when you are writing a C programming language with the help of pointers. Okay, so remember that when pointers are involved in your programs, C will be considered to be a low level language. So basically C is a middle level language. So if you involve functions in the C programming language, you consider it to be a high level language. Similarly, if you involve any of pointers, you consider the C to be a low level language. So to convert C from a high level language to a low level language, you are going to make use of pointers. That is the first reason. The second reason for using the pointers is you may have to return more than one value from a function. That is possible with the help of pointers. Then you can achieve pass by value with the help of pass by variable. We call it as pass by reference in fact. So in order to achieve pass by reference, we are going to make use of pointers, and we want to achieve something very similar to that of pass by value. We are going to make use of pointers again. So we have something called as pass by value, pass by reference, which are associated to the functions, which we will be discussing in tomorrow's class. So before pass by value and pass by reference, you want the basics of the pointers to be known. So we are going to discuss here in the pointers. Okay. So ma'am, then you said while initializing the size should not be specified. Yes, while initializing the size need not be specified. I did not say should not be specified, need not be specified. If the size is specified, accordingly the memory will be allocated. If the size is not specified, then according to the number of initializations you have done, the memory will be allocated. So need not be specified, it is not should not be. Okay. Ma'am, can we get these PDFs for our reference? Once the course gets completed, the PDFs will be added for your LMS. Okay, you can make use of it. Yeah. So I was talking about pointers, and these are the reasons why pointers are to be learned. Now, please understand what is a pointer. Okay. So I'll go with a very basic example. So if I take an integer variable, okay, I take an integer variable. What is the reason of me taking an integer variable called num? What will be a reason for taking an integer variable? Come on. So why will I take an integer variable in my program? If I have to answer it in short, I will say whenever I want to store an integer value, I'm going to make use of an integer variable. Correct? So I want to store an integer value. So I am going to make use of an integer variable. Now here the value I want to store is 5. 5 is an integer. I want that to be stored in a integer variable. Hence I have taken an integer variable called num, and num is being stored with the integer value which is 5. Okay. Now after num is being stored with an integer value, the next thing we want to do is, okay, so here I want the address of an integer to be stored. Okay, at some point of time I want the address of an integer to be stored. To store the address, I cannot go with an integer variable. Okay, so whenever I want to store an integer, so I will not, sorry, whenever I want to store an address of an integer, I cannot go with just an integer variable. I need a special variable called as the pointer variable. Okay, so there is a special variable called as the pointer variable, which is used to store the address of a variable. Okay, so pointer will have the address of the variable stored. Okay, so pointer will have the address of the variable stored. When will the microcontroller classes start? So once the C gets over. So it may take another 2 days, okay, to have the C module completed. Then you will have your microcontroller started. So I was talking about a special variable called as the pointer variable, which is used to store the address of the variables. So whenever you want the address of the variables to be stored, so you are going to make use of a pointer variable. Now how to declare a pointer variable is, so whenever you have a pointer variable, okay, so you will be able to store the addresses of these variables. You will be able to store addresses of multiple variables. So how to declare a pointer variable is, first you have to take the data type specified, then you have to take a star, and then you have to specify the pointer's name. So for example, if I say int star ptr, then ptr is a pointer used to store address of an integer. Okay, so ptr is a pointer used to store address of an integer. Then I will take character pointer CPTR. So what will I store inside CPTR? So CPTR is a pointer variable. Okay. What will I use to store inside this? Use to store what? Address of a character. Okay. So I will store address of a character inside CPTR. So address of an integer will be stored in PTR, and these names need not be fixed to PTR or CPTR. It is completely up to the user's selection. So I have taken int star PTR. PTR is a pointer variable used to store the address of an integer. CPTR is a pointer variable used to store the address of a character. Then I have got float star FPTR, which is used to store the address of a float variable. Okay. So like this, whichever variable's address you want to store, you are going to make use of a pointer variable. What are the benefits of pointers? We just listed them here. With the pointers, you can convert C from a high level language to a low level language. You can return more than one value from a function. You can achieve pass by reference. You can achieve similar results as that of pass by variable also. Now see, there is an integer variable called x. There is an integer pointer called ptr. So x will get 4 bytes of memory allocated. Let's say ptr is also getting 4 bytes of memory allocated. So please see here, the name of the pointer is just ptr. Don't say it as star ptr. So the name of the project is just ptr. Okay. Now x is returned with 5. ptr is also returned with 5. When x is returned with 5, please understand the 5 returned in the variable x will be an integer. Whatever is stored inside x, so that will be an integer data which will be used to do some operations. But when ptr is stored with the value 5, ptr is a pointer variable. What are you going to store inside the pointer variable? Always anything you store inside a pointer variable, what will it be? Please remember, anything being stored in a pointer variable will always be an address. Okay. So whatever you are trying to store inside a pointer variable will always be an address. So the 5 which I'm storing inside the pointer variable is not the data, it is an address. So it is address 5 which has been stored in the pointer variable. So anything stored inside x will be an integer variable. Anything stored inside ptr will be a pointer variable. I mean, it will be an address. So it will be address of a variable being stored inside the pointer variable. Now x is an integer which gets 4 bytes of memory allocated. How many bytes will be allocated for a pointer variable? Do you know how many bytes of memory will be allocated for a pointer variable? Okay, so please remember, whatever type of pointer you take, so it doesn't matter whether you have taken an integer pointer or a character pointer, what pointer you are taking. Okay, so it completely doesn't matter what type of pointer you are going to take. But remember, whenever pointers are being taken, so pointers will get 4 or 8 bytes of memory depending on the bitness of the system. Whatever pointer you take, you are going to store an address inside it. And size of the address will not depend on the data type. So whatever is the data type, the pointers are going to get 4 or 8 bytes of memory allocated. So pointers get 4 bytes of memory in a 32-bit system and 8 bytes of memory in a 64-bit system. So remember this, whatever is the type of the pointer, because pointers are meant to store the addresses. Addresses size depends on the size of the, bitness of the system. So in a 32-bit system, pointers get 4 bytes of memory allocated, and in a 64-bit system, pointers get 8 bytes of memory allocated. So size of the pointer is always fixed. So it will either be 4 or 8 bytes depending on the bitness of the system. Okay. So pointers are going to get 4 or 8 bytes of memory allocated depending on the bitness of the system. So it will be 4 bytes for a 32-bit system and 8 bytes for a 64-bit system. Okay. So that is about the pointer. Okay. Now this is x having 5 stored inside it. PTR is having 5 stored inside it. So pointers, you can say the both integer and pointers are not of same size. Pointers are 4 bytes in a 32-bit system, 8 bytes in a 64-bit system. Now there is a rule of the pointers which is talking about referencing and dereferencing operators. So referencing operator means ampersand, which gives you the reference of the variable, which is nothing but address of the variable. Dereferencing operator is star, which gives you the value of the variable. Okay. Referencing operator is ampersand, dereferencing operator is star. Now, whenever you see a dereferencing operator, please read it as go to. Okay. Not the go to statement. So it is verbally go to. So wherever you say wherever you see a dereferencing operator, you can read it as go to. So we have two types of operators to be used in the pointers. One is a referencing operator. The other one is a dereferencing operator. Now what happens here is, I have a simple example. There is an integer variable called x with the value 5. There is an integer pointer called PTR. So assume mine is a 32-bit system. So pointer is getting 4 bytes of memory allocated. And because I have not written anything into the pointer variable, it is initially having a garbage value. X is returned with the value 5. Now, what do you think the below line gives? What do you think star 1000 is going to give me? So whenever you see star, as I said, please read it as go to. So I am telling go to 1000. When you go to 1000, what do you end up getting? When you go to address 1000, what do you end up getting? Come on, when you go to address 1000, what do you end up getting? So you have the value 5 in the address 1000. So whenever I say star of 1000, so whenever I say go to 1000, you're going to location 1000 and fetch its value. So star 1000 should give you the value 5. When I say star 1000, please, I'm saying you have to read it as go to 1000. When you go to 1000, there is a value called 5. So 5 will be stored in, 5 will be obtained when I do star of 1000. Now the question comes is, how to get this 1000? How to get this 1000? How will I be able to get this 1000? So 1000 is an address of the variable x. Okay. 1000 is address of variable x. So how to get address of variable x? You are going to make use of the referencing operator called ampersand. So when I say ampersand of x, I am going to get 1000. So this I can store it into a pointer variable called PTR. Okay. So I'm going to store it into a pointer variable called PTR. So when I do PTR is equal to address of x is 1000, PTR is going to get 1000 stored. How to tell star of 1000 using PTR? How to tell star of 1000 using PTR? PTR is having the address 1000 stored. So when I say star PTR, it literally represents star of 1000. So it goes to address 1000 and gets me the value 5. You can see here there is an integer variable called x, a pointer variable called PTR. X is assigned with 5, PTR is assigned with address of x. So address of x is 1000. So 1000 is stored inside PTR. Okay. So now address of x is stored inside PTR. Star of PTR will give you the value of x. Okay. So address of PTR is 1000. Sorry, address of x is 1000. Star of x will be, sorry, I'm very sorry. Address of x is 1000. Star of PTR gives you the value 5. So I was seeing this something. Star PTR is equal to address of x. So somebody is saying this. Okay, I don't know what the name is. So somebody is saying star PTR is equal to address of x. So let me note it down here. Okay. So here somebody is saying star PTR is equal to address of x. Now what happens with this problem is, okay, there's a problem here. So you cannot have star PTR return with address of x. So PTR initially is not representing any value. So it can be some garbage value. Okay. So what PTR has is some garbage value. So assume my garbage value is 1, 2, 3, 4, 5, 6. Okay. So I'm just taking some garbage value as 1, 2, 3, 4, 5, 6. So into this address 1, 2, 3, 4, 5, 6, I'm trying to store address of x, which is 1000. Now star always says go to. When you say star PTR is equal to address of x, it goes to address 1, 2, 3, 4, 5, 6, and it is having 1000 return inside it. Should I write 1000 into the address 1, 2, 3, 4, 5, 6? So when I say star 1, 2, 3, 4, 5, 6, it says go to address 1, 2, 3, 4, 5, 6 and have an address of x return. Should I go to address 1, 2, 3, 4, 5, 6 and have 1000 return? Multiple sounds. Somebody's mic is on. I'm not sure what the issue is. Multiple sounds, disturbances. I have muted all. I have muted all the participants. Do you still see the disturbance? You don't have any? Okay, fine. Yes, let us continue. Yeah, I was saying something like this. If you write star PTR is equal to address of x, that is wrong. So PTR is having some garbage initially returned. So when I say star PTR is equal to address of x, you are going to address 1, 2, 3, 4, 5, 6 and you have value 1000 return. So this literally says go to 1, 2, 3, 4, 5, 6 and have the 1000 return, which is wrong. So you have to write 1000 to PTR. So the valid way of doing it is PTR is equal to address of x. So PTR is a variable which stores address of x 1000 inside it. So address of x is stored inside PTR. Star of PTR gives the value of x back. Okay. So that is nothing but the example. Now if I have a similar example here, you please try answering. There is a number there is a variable called number. Okay. So I'll write it as a number here. So this variable number is initially assigned with the value 10, and just assume it is from the address 1000. Okay. Then I have one more pointer variable called PTR. Okay, so assume mine is a 32-bit system and PTR will get 4 bytes of memory allocated. So this is PTR, which is present in the address 2000. Okay, and this is initially having some garbage value. Now what it says is PTR is equal to address of num. So what is address of number? What is address of number in this example I have taken? So address of number in this example is 1000. So PTR is assigned with 1000. So here I will have 1000 stored. Now can you please answer what is the output of these two printfs? So I have taken a similar example. There is number stored with the value 10 in the address 1000. PTR is getting the memory allocated from the address 2000. And the PTR is equal to address of num. So address of num is 1000. It is stored inside PTR. So what is address of number and what is PTR? So address of number you can evidently see it is 1000. Okay. So address of number is 1000. What is stored inside PTR is 1000. So both of them will give you the answer as 1000. What is the difference between PTR and star PTR? So there is a very large difference between PTR and star PTR. Let me make you understand it. PTR is a pointer variable. What is PTR representing in this diagram? What is PTR representing? Yes, PTR is representing the value 1000. PTR is a pointer and pointer will always have an address stored inside it. So PTR here is representing 1000. When you say star PTR, you are supposed to read it as go to. So here I have a star PTR. PTR is representing 1000. I will tell go to 1000. What do you get when you go to address 1000? So yes, when I go to address 1000, I will get the value 10. So PTR and star PTR are two different entities. PTR always represents the address, star PTR always represents the value. Now the same example, I don't know how to select that. Okay, so I am going with the same example here. I have to print the value of number and star PTR. So this program, I want the same representation, so I cannot go there. Let me directly ask you, what happens if I print number here and star PTR here? What are you getting if I print number and star PTR? What will you get if you print number and star PTR? Number is having 10, so 10 will be printed. Star PTR means it is star of 1000. Star of 1000 means it goes to address 1000, which has a 10 return inside it. So star PTR should also give you a 10 printed as an output. Okay. So number and star PTR will have 10 and 10 printed as an output. Got this? Are you able to follow the pointers? Okay. Now, okay. So by compiling and executing, I can say star PTR is equal to number. You see this example itself. Number and star PTR are same. Okay. So number and star PTR are always same. Similarly, remember address of X and PTR are always same. Okay. So address of X and PTR are always same. Number and star PTR are also always same. Okay. Have a star PTR 10. So I'm clearly representing here. So PTR is having 1000 stored. Star PTR means go to address 1000. When you go to address 1000, there is a value 10 stored. So 10 has been printed as an output. Don't concentrate on percentage P. So percentage P is a special format specifier which is used to print the address in the hexadecimal format. So don't worry about it. You just ignore. Okay. Then we have a rule of the pointer which says pointing means containing. Okay. So whenever you take a pointer, we say pointing means containing. What does that represent us? So if you take a pointer variable here, so first there is an integer variable called a returned with the value 10. So a is written with the value 10 here. Then I'm doing int star ptr. I took a pointer variable. Ptr is equal to address of a. So I am trying to store address of a into the pointer variable ptr. So address of a here is 1000. So 1000 is stored into the pointer variable ptr. After this, when ptr is storing the address 1000, pointer will be pointing to that particular address. Okay. So how is it 1000? Since star ptr has to refer to the value of the pointer, that is 1000. No. Just ptr is representing the address 1000. Not star PTR. Just PTR is representing the address 1000. So it is like number. When I say number, what does it represent? It represents the value present inside this. When I say number, it represents 10. When I say PTR, it represents 1000. When I say star PTR, it is star of 1000. Can integer pointer points to a character or a string variable? Yes, it can. But that is not something allowed. Okay. So yes, let us get back to this. So we have a rule of the pointer which says pointing means containing. So there is a pointer variable ptr representing the value 1000. So when ptr is having 1000 stored, it is pointing to the address 1000. So we say pointing means containing. Okay. Then there is one more thing with respect to the pointer. So because we are talking about data fetching, so we have something called as endianness. Endianness means we have two types of endianness. One is a little endian, the other one is a big endian. So if I start this little endian and big endian, it will be difficult to finish it right now. So about this pointer concept, we will see it in tomorrow's class. So tomorrow we will go with little endian and big endian, and we have something called as null pointer to be discussing about. Then we will move to the functions. Okay. So the rest we will continue in tomorrow's class. So today we just discussed on ternary operators, overflow and underflow, and the array, and also some of the basics of the pointers. I hope it has been clear. I'm going to stop it here and we will continue tomorrow. Okay. So thank you all. Have a good day.